So hello guys, and good afternoon everyone. So to formally start with, let me introduce myself. I'm Kyle Regasa from this IT Abyss 22 evening. So we actually have here a circular queue. So something on circular queue. So a circular queue is a special version of a queue where the last element of the queue is connected to the first element of the queue, forming a circle. So the operations are performed based on the FIFO or first in, first out principles. It is also called ring buffer. So in a normal queue, you can insert the old elements until queue becomes full. But once queue becomes full, you cannot insert the next element even if there is a space in front of the queue. So naay path operations on a circular queue. So first we have front. So on front, the summary is get the front item from the queue, and rear they get the last item from the queue. So NQ value. This function is used to insert an element into the circular queue. In a circular queue, the new element is always inserted at the rear position. So na nakabot under line of code, so check whether the queue is full. So visible naman siya dire, nakita. Makita na to. So if it is full, then display queue is full. If queue is not full, then check if rear is equals to size minus 1 and front is not equals to 0. If it is true, then set rear to is equals to 0 and insert an element. So gingon dire nga so we actually have here a DQ. So DQ, this function is used to delete an element from the circular queue. In a circular queue, the element is always deleted from the front position. So same as a kanang normal na queue nga ang if ever mag-add tag element, ang add to mabutang sa rear. While ang sa front, dito na makita ang deleted queue. It's always deleted from the front position. While add element in queue value is function is inserted into the circle. In a circular queue, the new element is always inserted at the rear position. As what I've said, NQ is add to ang add nga value is add to mabutang sa rear position, while ang deleted value adto mawa ngadto sa front position. So we actually have here a block of code. So we have here a example code for a circular queues. So to start with, so siyempre nag-declare tag package circular queues. So something gamit ang package circular queue. So in the context of a Django program, kaning package mo, it helps us to organize a set of related classes and interface. Next is we have here a Java import java.util.re.lens. So here nag-import tag array list class from the Java util package. So this will allow us to use dynamic arrays in the code. Next we have here class circular queues. So something class circular queue. So nag-declare ta og to start ato ang class na declare ta class circular queues. Next we have here a declaration of size, front, rear, and integer variables. So this will be used to keep us the track of the size of the queue and the position of the front and the rear elements. Next we have here an instantiate tag array list called queue that will hold the integer values. So it will serve as the data structure for our circular queue. Next we have here a circular queue class is defined. It takes an integer size as a parameter. It sets the size of the queue and it initializes the front and the rear pointers to -1. So this dot front is equals this dot rear is equals to -1. So nag-indicate na siya nga ato ang Q at first is empty. Excuse me. Next we have here public void NQ ain't data. So nagwa that NQ method in where we used to and where it is used to add elements to the circular queue. These specific sections check if whether the queue is full using condition that tells if the front is at the beginning and the rear is at the end, or if the rear is just before the front in a circular manner. Excuse me. Else if front is equals to -1. So if the queue is not full and the front is -1, it indicates that ito ang queue kay empty pa. So this part initialize the front and the rear and pointers to 0 and adds the data to the queue at the position of the rear. Next we have here else if rear is equals to size -1 and front is not equals to 0. So this section handles the case whether when the rear is at the end of the queue but the front is not at the beginning. It sets the rear is equals to 0. So Q that sets is and the sets data that the position is at the queue. Else rear is equals to rear plus 1 if front is less than or equal to rear is Q that rear that data, or else Q that set rear data. So if none of the previous conditions are met, this part increments the rear pointer in a circular manner. So mag-increment na siya depending on the relation between the front and the rear positions. It either add the data to the queue or sets it at the rear position. The remaining excuse me. Now we have here the public int EQ. So sabi namin ito yung public int EQ. So na-declare the public int EQ method is used to remove an element from the front of the queue. This part checks if the queue is empty by verifying if the front is -1. If it is, it prints a message indicating that the queue is empty and needs to return a -1 value. So next we have here front is equals to rear and front is equals to -1 and rear is equals to -1. The front and the rear are at the same position, indicating that nag-indicate ni siya nga ang kaning position na to within sa time is naa sa nag-usarabok element. In this section sets both the front and the rear to -1, effectively implying the queue. So else if front is equals to size to -1 and front is equals to 0. If the front is at the end of the queue, this part sets it to the 0, ensuring the circular nature of the queue. Or else front is equals to front plus 1, return temp. If none of the previous conditions are met, the front pointer is simply incremented to remove from the element from the queue, and the temp variable holding the removed element is returned. Next we have here the public void display queue. So the display method is used to display the elements of the circular queue. This part checks if the queue is empty by verifying if the front is -1. If it is, it prints a message indicating that the queue is empty and then returns from the method. Then print out the message na elements in the circular queues are if rear is greater than or equal to front. So nagamit ang for loops series for 4 loops, and I is equals to front, I is less than or equal to rear, then increment I. So system out if the rear is greater than or equal to the front, the sections runs a loop from the front to the rear and prints each element in the queue along with the space. It then prints a new line. Or else, for int I is equals to front, I is equals to side, I plus. So kaning loop diri dapita in duha ka for loops. If the previous condition is not met, it means the queue wraps around. Also, this part runs two loops. The first loop runs from the front to the end of the queue, and the second loop runs from the beginning of the queue to the rear. Both loop prints elements along with the space. Finally, it prints the line. Here, napit sa public class CQ. So, this line starts the definition of the CQ's class. So we have here public static void means string args. The main method is the starting point of the Java program. It is required method and is called when the program is executed. Here it takes an array of strings args as a parameter which can be used to pass command line arguments to the program. So circular queue is equals to new circular queue. So this line creates an instance of the circular queue class called queue with a capacity of 5 elements. So we have here value added queue sa ato ang queue. Nag-set ang value ng 14, 22, 13, negative 6. So this lines enqueue 4 elements in the circular queue using the enqueue method. So then after that you display the elements in the circular queue. Int x is equals to q that dq if so this line dequeues an element from the circular queue and stores the value in the variable x. So here sa ato ang if statement, so there's this if block checks if the decreed value is not equals to -1, indicating that the DQ is successful. If it is not -1, it prints a message indicating that the deleted value. Next we have here x is equals to DQ. If x is not equal to -1, no print out siya deleted value. System out to this line requires another DQs another element from the circular queue and store the value in the variable x. Next we have here if x is not equals to -1, similar to the previous if block. This one also checks the DQ'd value. X is not equals to -1, indicating a successful DQ. If it is not -1, then it prints a message indicating the deleted value. Next we have here is display queue. This line again calls the display queue method to display the elements in the circular queue after performing the DQs. So ma-print out na lang ano nila, okay? These lines into 3 more elements, 9, 20, and 5 into the circular queue. This line calls the display queue method again to display the elements in circular queue after the execution of in queues. So q and q20, this line attempts to enqueue another element 20 in the circular queue. However, the previous implementation of the enqueue method does not properly handle the case which when the queue is full, so this call may not work as expected. So that's it. That's how we so let's try to run the program and let's see what's ang output. Let's try to run it. So we have here the elements in the circular queue are 14, 22, 13, 16. So kaning set of numbers was given by a predefined value na siya kay dili ulit siya gihatag sa user, which is nasa condition within the condition na siya. So 15, 22, 13, and 86. So we have here two deleted values from our main program. Matugin yun dire nga sa ato ang DQ 14 and 22. So elements the circular cube after deleting two values is 13, negative 6. Elements equal to Q are 13, negative 6, 9, 20, and 5. Which is na dali. Nilagdag ato nga value from in Q. And this 2 and Q which is hindi na siya display because nga nalapas naman siya sa atong sa capacity nga element 5 ra. So that's all and thank you.